Okay, so next we look at the surface integral of vector field. So for this, the physical interpretation of the surface integral of vector field is we can evaluate the fluid flow that passing through the surface, where the fluid flow is given by the vector F. Okay, where we can say that we are computing the flux. Before we go further, there are some terminologies that you will see over and over again in this particular section, where the first one is orientable surface. Orientable surface is orientable if we can obtain the unit normal vector of the surface. So let's say you are given a random surface. So let's say you want to get the how can we say that the orientable surface, so that this surface we can obtain the normal vector or unit normal vector, where the positive one, if we have the positive orientation, if okay, so the surface here, the orientable surface here is positive orientation if the unit normal is point outward. Okay, but if it is negative, if it is point inward. So that is the thing that you have to know about the positive orientation, okay, for the unit normal vector. And another thing is a closed surface. Okay, so there is a possibility that your surface here, it is closed. So a surface sigma is closed if it is a boundary, the boundary of some solid G. For example, you have the sphere. So as we know that the sphere is closed, right? So that surface sphere is the closed surface. And also we have a surface of a solid ball or a surface of a solid cylinder. Okay, when there is a word, just like the thing that we have looked at in chapter 3, I mean from the multiple integral, especially for triple integral, if sometimes your solid can be your surface can be closed. Okay, so when we have the closed surface, we call that as a solid. Okay, so this is the graphical diagram of the unit normal to the surface point outward, so it is positive. Okay, so this one is the, let me enlarge this. So in general, let's say you are given a surface sigma. Okay, so this is open surface, right? And the boundary of the surface here, the open surface here, is given by the curve C. Okay, so this one has to do with the line integral. So where we can see this in the next few section. The relationship between the surface integral and line integral can be obtained in the Stokes theorem that we will discuss later on. Okay. And you can see here the end, unit normal to the surface is always point outward, and in this case the direction along the C is counterclockwise. So this is in general what we can have for the surface integral for vector field. Okay, so you need to apply the right hand thumb rule later on when we want to deal with the relationship between the line integral and surface integral. Then you have to apply the right hand thumb rule. Okay, so for a general surface sigma in space, each element of surface ds, which is the patch, okay, has a vector area. So what we can have is the ds, this is vector, okay, is the same as the unit normal vector and multiplied by the surface ds, where we can say that okay, we use this one, okay, actually to convert from the f dot ds. This is the original form of the line, the surface integral, where when we have the vector field, okay, so you should have f dot ds, okay. But since we are using this formula or this equation, so this one can be transformed into when we know that ds here, it is a vector, is equal to n is a unit normal vector multiplied by ds, so it can be converted into this one. So this one is actually ds. So now we have f dot n ds, okay. But as I mentioned from the previous surface integral for scalar field, we don't use the ds, but we use the dA. So now we have to know what is the calculation which is needed for us to convert from ds into dA, where the process, the procedure is not the same as the surface integral for scalar field. It is a bit different, and I would say totally different, which is it is more steps are needed, okay. Okay, so in general, when we are looking at the definition, 5.6 here, if we use the formula of ds that we apply for scalar field, for the surface integral for scalar field, so we in this case we apply the same. So where ds is the square root of zx squared, zy squared plus 1 if your surface function is z in terms of xy, okay. But then as I mentioned before, you need to provide extra step because you have to find the unit normal to the surface given, okay. But for the if we have the to get the surface integral for scalar field, is just enough for us to only provide this one. But for vector field, so you need to also determine the unit normal to the surface, okay. So this surface integral is also called as a flux of the given vector field across the surface given. Okay, so how it's work. So we can use the surface integral to calculate the flux of a vector field f, okay, and the vector field is point outward through the surface S. So it's passing through this what color is this, brown surface, okay, where the surface is given by this equation. So this is, I would say, this one is the sigma, okay. So from the sigma here, we can evaluate the normal vector. Okay, so if your surface function is y is in terms of xz, then this is your ds. And similarly, if your sigma surface equation is given by x in terms of yz, and this is your ds. Okay, but in this the calculation for surface integral where we have the vector field here, I'm not going to use the small n. Okay, so I have a more simpler, okay, for me it is a more simpler step, rather than you have to obtain the normal vector and then find its normal. So it's something you need to provide extra work where actually you can simplify that one after a few steps, so we can just skip a few steps. Okay, what I want to say here, we don't need to use the small n, but we just use the normal vector where just keep capital N. Okay, and how can we get the capital N here? As we have discussed on the gradient phi or gradient f. So normal to the surface, remember that. So what is the formula? So for the normal vector, it's just compute the gradient f. Okay, gradient f. So this will give you a normal to the surface. So you don't need to compute the magnitude, because after that the magnitude can be cancelled out by other terms. So we don't want to wasting our time. So we just compute the normal vector to the surface. Okay, so I will explain to you the process, the steps from the example that I show you. Okay, so in this case I will skip this because there is no point if I explain this now. So I'm sure that you have no idea. So I will explain through some example. Okay.